Before we get started, I'd like to thank our sponsors, especially InstaSecure. InstaSecure is a proactive breach prevention cloud security platform. It prevents credential theft and zero-day attacks, the leading causes of cloud breaches. InstaSecure automates a data perimeter, ensuring only trusted identities access trusted resources from expected networks. As always, questions after the talk. Please welcome Nick Frichette.
No? Oh, can you hear me now? Okay, awesome. Hey everyone, thank you so much for being here. Hope everyone's had a great start to Forward CloudSec. It's great seeing everybody in person. I think we're in a really interesting time in AWS security. Last year, AWS announced their intention to move to an all IAM DSv2 future for EC2 instances, and they've taken a number of steps to mitigate use of IAM DSv1. Additionally, while I don't know that we'll ever truly be rid of IAM users and their long-lived access keys, I think more security teams than ever are aware of the risks that they pose and are taking the steps to replace them with more secure alternatives. These two factors combined represent a significant reduction in potential initial access vectors for an adversary. If you put yourself in the shoes of a ransomware operator, a crypto miner, or other digital criminal, how else are you going to afford that next Lamborghini if you can't rely on these tried and true methods? So in this session, I want to sell you on an idea. We can gain initial access to an AWS environment by abusing pre-existing trust. What we mean by that is a common design pattern in AWS is to have an IAM role in the account that has a trust relationship back to some AWS service. This is for things like EC2, Lambda, and other compute services, things like Glue for ETL jobs, or auto-scaling groups to manage your resources, and so on. What we're going to be looking at in this talk are two vulnerabilities that allowed us to hijack this trust relationship and gain access to the AWS account as those roles. So to go through this, we'll start with a quick level set on how trust is established in AWS, particularly with role trust policies. Then we'll take a look at those two vulnerabilities that I mentioned that allowed us to abuse that trust to gain access to a victim's AWS account. And finally, we'll talk prevention options. In the absolute worst case scenario, if an adversary has a cross-tenant zero-day in AWS and is targeting your organization, what options do you have to try and block that or mitigate it? Really quick, it's important to note all of the vulnerabilities we're going to be talking about today have since been fixed by AWS. So think of this more from the perspective of what can we learn from these vulnerabilities that we can apply to better defend or attack cloud environments. Now, on the topic of abusing pre-existing trust, we should probably talk a little bit about how that trust is established. In AWS, every IAM role will have a role trust policy, and that policy determines who or what is allowed to assume that role and under what condition. And these policies have a lot of familiar elements that you might recognize from normal identity policies. So things like the effect, which is an allow or deny, the action, this is the particular flavor of assume role that you're using, whether that's assume role with web identity, assume role with SAML, and so on. Finally, for our purposes, what we're mostly interested in is the principal. This is the specific AWS identity that is permitted to assume the role. And that could be a wide variety of factors. An IAM user, a role, an entire AWS account, and so on. So if we were to read this policy, what it says is that we're going to allow the AWS account 11111 the ability to assume this role. Another wildcard that's worth pointing out, another principle that's worth pointing out is called the wildcard trust policy. The wildcard would permit any AWS principal the ability to assume this role. Not just in your AWS account, not just in your AWS organization, anybody else with an AWS account could assume this role. And the reason I bring this up is we're going to be looking at some trust policies that are logically equivalent to this, that would allow anyone the ability to assume a role. Now, I think where trust policies get interesting is when the principal ties back to some AWS service. What's on the slide currently is the default trust policy that you would get if you were creating a Lambda function and had it create a role for you. And what it says is that we're going to allow the Lambda service the ability to assume this role. Now, what's interesting about this is that basically everybody's trust policy for Lambda will look like this. And under normal circumstances, what you would do is you create a Lambda function in your account, have it create a role for you, and then your role, or the Lambda service will assume that role in your account to do whatever it is you programmed it to do. Well, if we've already established that the trust policy determines who can assume a role, and everybody's trust policy is the same, allowing the Lambda service to be able to assume it, what's to stop me from creating a Lambda function and pointing it at a role in a different AWS account, one that I don't own? Well, the good news or the bad news, depending on your perspective, is there is something that stops you, and that's called pass role. Anytime you pass a role to an AWS service for it to assume, this is the mechanism that you're using. And if you try to pass a role to a different AWS account, you get an access denied. Cross-account pass role is not allowed. To be clear, this is different than having pass role permission. Even if you have administrator access, star privileges, you can't just pass a role to somebody else's account. One of the core mechanisms or tenets of pass role is that it can only be done in the same AWS account. And this is a good thing, right? The last thing we would want is for an adversary to be able to arbitrarily choose a role in somebody else's AWS account and abuse a pre-existing trust relationship to some service to assume that role. And that's what we're going to be looking at in the first vulnerability we're going to cover today, confused deputy vuln in AWS AppSync. If you're not familiar with AppSync, AppSync is a managed GraphQL service offered by AWS. It allows you to quickly and easily build GraphQL applications and configure them and so on. To oversimplify quite a bit how AppSync works, you first create an AppSync API in your account, configure it, set the schema, and so on. And then either you create or you have AppSync create for you an IEM role. Every time your AppSync API runs, the AppSync service will assume that role in your account to do whatever it is that you have it set up to do. Write to DynamoDB, interact with RDS, publish a file to S3, and so on. The core tenet here is that the AppSync service assumes the role in your account to perform some action. Now, like we've seen before, the default trust policy for AppSync is just tied back to the AppSync service. And similarly to what we saw before, if you try and pass a role to somebody else's AWS account, once again, access denied, cross-account pass role is not allowed. But this time, we have a way around it, through the power of SpongeBob. See, it's important to note that AWS APIs are case sensitive. What we mean by that is whenever you pass a parameter to the AWS API, it expects it in a very particular casing and naming convention. As a random example, just to demonstrate this, the secrets manager create secret API call expects a name parameter, and it expects it with a capital N. So long as you provide it in that format, you get a 200 OK, everything works out, you've created a secret. However, if you deviate from that in any way, even just changing a single character, when you try to send that to the API, it complains. 400 bad request, member must not be null, because you didn't provide the parameter it was looking for. You may have provided the right alphabetical characters, but the actual parameter it's looking for wasn't in the payload, so it acts as if it doesn't exist. What was interesting about this with AppSync is that it was not case sensitive. You could pass parameters with arbitrary casing, and it would take it just fine. To be clear, it didn't drop the parameter. It actually still used the contents of it. And the reason this is interesting was the way you would pass a role to the service was through the service role ARN, capital R, capital A. And if you tried to pass a role to a different AWS account, well, 403 forbidden, cross-account pass role is not allowed. But if you changed a single character in that parameter, any character at all, in any way such that it wasn't expecting it, 200 OK. It went through just fine. Yeah. Thank you. So through the power of SpongeBob, we were able to defeat a major tenancy boundary in AWS. This would allow us to pass to that service any ARN that we wanted to, including in other people's accounts that we shouldn't really have access to. This is an example of a cross-service confused deputy attack, where a lower privileged identity, us, is able to convince, trick, or coerce a higher privileged entity, in this case the AppSync service, to do something on our behalf. And in this case, we're able to cause the AppSync service to assume arbitrary roles in a victim's account of our choosing. And again, the reason this is possible is because of that pre-existing trust relationship between that victim IAM role and the app sync service. Now, from here, if you've ever done cross-tenant attacks in AWS, you'll know that assuming a role is only half the battle. From there, you have to actually do something with that access or have the ability to perform something meaningful to an attacker. The good news for us is that AppSync is happy to provide. In particular, one of its features or capabilities is that you can invoke arbitrary AWS APIs. So if there's a particular call we want to make, AppSync can do that for us. So for a real-world example of how we would have abused this if we didn't, or if we wanted to break the law, would be to create an AppSync API in our account, configure it, set the schema, determine what API call we want to make, do the pass role bypass, point to a role in a different AWS account, and then whenever we would execute our API, instead of the AppSync service assuming a role in our account, it would instead assume a role in the victim account and perform that API operation. And that's how, in this particular screenshot, we're running the DynamoDB scan operation to dump a database cross-tenant from somebody else's account. Although this is a demo, we do actually own this account, so no laws have been broken here. If you'd like to learn more about this vulnerability, AWS did release a security bulletin for it, as well as we have a very detailed blog post with additional details, contents, and more. And this takes us to the second vulnerability we're going to be talking about today, the AWS Amplify service exposing IAM roles to take over. To get us started on this conversation, we first have to talk a little bit about Cognito. If you're not familiar, Amazon Cognito is a sign-in as a service offering from AWS. If you don't want to handle securely storing user credentials, hashing, salting, password resets, and all that boring stuff, you can pay Amazon a small fee, and they will do that for you. One of the major features of Cognito is something called an identity pool. And this is a resource that would allow you to distribute to your users short-lived IAM STS credentials. So say, for example, you're building a web application or a mobile app, and you want your users to be able to upload a file to S3 or invoke an API gateway using IAM auth. This would be the easiest way to do that. Now, the trust policies on the roles associated with Cognito are a bit more complicated than what we've seen so far, but they do have a really interesting inclusion. If we were to read this policy, what it says is that we're going to allow the federated principal Cognito identity, so the Cognito identity service, the ability to assume role with web identity under the condition that the AUD value, the audience value, is set to a particular string, and that the AMR, the authentication methods references, is set to authenticated. What this condition is doing is basically blocking or setting where you can be coming from in order to assume this role. And that particular string is the identity pool ID associated with this role. And so it appears that the developers of Cognito foresaw an attack like what we did with AppSync, where an adversary could be able to coerce or trick the service to assume a role of our choosing. And to prevent that, they set this condition by default, which limits what identity pool can assume it. So for instance, with this condition set, I couldn't create an identity pool in my own account and then assume that role. So interesting. It's curious that they had that foresight or were concerned about that. And it leads to the question of, OK, cool. If that condition doesn't exist for any reason, can we assume this role cross-account? Well, it's easy enough to test. Create an identity pool in your account. Create a role with that trust policy in a different account. And then try to set that role with set identity pool roles. And it failed. Once again, cross-account pass role is not allowed. And so it's curious that the developers felt the need to include this condition when theoretically the control that's, for lack of a better term, like considered good enough for EC2, Lambda, AppSync would normally block it. And this was something we were deeply curious about until turns out there was a way around it. In order to describe this, we first have to talk about the Cognito auth flows. There are two auth flows currently in use by AWS, and what these are essentially like step-by-step procedures by which your users, whether they be authenticated or unauthenticated, can generate those STS credentials. The two auth flows currently in use are the enhanced auth flow and the basic auth flow, sometimes referred to as the classic auth flow. Now, for our purposes, we are primarily interested in the basic offlow because the final operation in that procedure is assume role with web identity. And the reason we care about that is because that particular API call has a parameter for role ARN, allowing us to specify a different role in somebody else's account. And so the way we would abuse this is create an identity pool in our own account, configure it, make it use basic offlow, and then perform the getID and the getOpenID token API calls against that identity pool. This will return a JWT that we will then pass into assume role with web identity, along with the ARN of a role that had that misconfigured trust policy, and this time it worked. We could assume a role cross-account by using our own identity pool so long as they had that misconfigured trust policy missing that condition. It appears that assume role with web identity does not have the same protections that normal past role would normally provide. And so for our purposes, we can refer to this as the variant 1 vulnerable trust policy, just trusting the Cognito identity service and without a condition. And if we call back to when we looked at the wildcard principle, this has the same logical effect. Anybody with a credit card to an AWS account could now assume a role in your account. They are, it's essentially opening a role to the world to allow it to assume. Now, you might be wondering, well, Nick, why are you specifying this as variant 1? Well, it's because there's a variant 2 as well. In the default trust policy, you might have noticed the second condition, that AMR, and wondered if that condition is set, can we assume the role? And the good news is we totally can. In particular, if the AMR, the authentication methods references, is set to unauthenticated, then all the steps we already covered work literally identically. No changes are required. If the AMR is set to authenticated, then we do have to jump through some extra hoops. In particular, we have to create a user pool in our own account, configure it with that identity pool, and then after doing that, basically all the same steps apply with very little changes. All this condition is doing is checking you're authenticated to an identity pool, not that you're authenticated to a specific identity pool. And so we can refer to this as the variant 2 vulnerable trust policy. Again, anyone in the world could create an identity pool and then just jump into somebody's account that has this trust policy set. Now, really quick, because this is for CloudSec, if this sounds vaguely familiar, this idea of there's a trust policy on a role back to some service, and if that trust policy is missing a condition, suddenly anybody can jump into your account, and you're feeling deja vu, I don't blame you, because this exact same story played out last year. This time, though, rather than Cognito, it was GitHub to AWS OIDC integration. To make a very long story short, a number of researchers, including my own colleague Christoph, identified that the default trust policy on those roles looked like this. And this might look very familiar. The difference being, rather than the audience value being what secured the role, so to speak, this time it was the subject value that actually determined what organization or what repo you were coming from. And those researchers determined if that condition didn't exist for any reason, now anybody with access to GitHub who could create a GitHub action could now just pass in the role the ARN to your role and assume it. It's very similar to what we've described so far. I bring this up for 3 key reasons. One is to demonstrate that this is a general problem. Anytime you have a assume role with web identity trust policy that it has a principle that is global or that anybody can act through, and there's no condition limiting where you're coming from, anybody would be able to assume that role. It's not specific to GitHub, not specific to Cognito, or any other services that are affected. Speaking of which, the second reason I bring this up is, up until this point, AWS has kind of played whack-a-mole with the situation. So like I said, last year, a number of researchers started posting about this, and to AWS's credit, they did react to it. They made a change such that you can no longer create a role with a trust policy like this one. If you tried, the API will actually reject it and block you from being able to do so. And so that's great. They're preventing future roles from being misconfigured. If there is a problem, the problem is it's a very specific fix for just GitHub. Things like Cognito, which we took a look at, weren't fixed. Other services that have a very similar misconfiguration weren't fixed either. A little bit of a foreshadowing / spoiler warning. As a part of our disclosure, AWS did make some changes to Cognito, and they actually kind of went They sort of took the nuclear option. We'll talk about what that means in just a little bit. If you'd like a sort of summary around the GitHub Actions thing, Scott Piper has a really good blog post sort of summarizing it. The third reason I bring this up is the CFP for CloudSec EU is still open. And if you wanted to submit a talk, finding other services that have this potential misconfiguration would be great. If you'd like a freebie, the GitLab runners trust policy is basically identical to this and has the same issue, and you can still abuse that or exploit that today. Now, you might have noticed I called this a misconfiguration, and that's because it is. This is not, the GitHub Action stuff and the Cognito stuff is not a vulnerability. Had you experienced a breach, a compromise, or other security incident, and you told AWS about it, they would have invited you to a lovely Chime call. They would have shown you this diagram of the shared responsibility model, and they would have drawn a big red X around the customer side and said, good luck, champ. And so you're probably wondering, well, Nick, I was promised a vulnerability. You're calling this a misconfiguration. What gives? Well, this is where the situation gets weird. See, earlier this year, when we discovered this capability in Cognito, one of the first questions we had was, OK, cool. I wonder how common this misconfiguration is. And especially because it could be used for initial access, literally just assume rolling into somebody's account, we were curious if we could use publicly available information to find vulnerable roles and then notify their owners so that it could be fixed. And so to do this, we used a tool called SourceGraph. Not sponsored in any way, but one of their free features or offerings is essentially like a Google search, but for public GitHub repos. And so what we did was we wrote a regular expression for IEM role ARNs. Threw that into SourceGraph, got a bunch of results, and then deduplicated them, removed clearly placeholder ARNs, so like ARNs with account IDs that were all one digit or incrementing digits, things like that. And that left us with a little over 8,000 results. From there, we then tried to assume each role twice. Once unauthenticated, once authenticated. And we let the automation run, and within seconds, it was very clear something horribly wrong has happened. Remember, this was across all of public GitHub, across teams, organizations, individuals, and companies. So why was it then that the overwhelming majority of roles we found vulnerable all had this weirdly specific naming convention? What you see here on the slide are real roles that we found in the wild that were vulnerable that we've slightly modified so as to protect the identity of their owners. Now, what's weird about these roles is that they all ended in either auth role or unauth role. And additionally, they appear to have either a timestamp dating back to 2018 or 2019, or they had a 6-digit integer. Presumably, these were the newer ones. And to make things even more weird, as we were digging through the data, we found 3 roles that belonged to AWS that was vulnerable. And so at this point, we weren't sure if this was like a tutorial gone wrong, where somebody was demoing something, not realizing that it was vulnerable. Using SourceGraph, we were able to see the name of the file where these roles were found. And again, the overwhelming majority were found in a file called teamproviderinfo.json. And this ultimately took us to the culprit. It was AWS Amplify. Normally, when we talk about a misconfiguration, we're talking about a misunderstanding, a mistake, developers moving a little too fast and breaking a little too much, or not realizing that something is exposed. This is a rare circumstance in which the AWS service actually misconfigured customer resources and exposed them that anybody in the world would be able to assume them. The vulnerability was not that you could misconfigure roles. The vulnerability was that AWS misconfigured those roles. And they didn't just do it once. They did it twice. If you're not familiar with Amplify, the general idea behind it is that it's a framework that allows you to build web and mobile applications. Developers can focus on their code, and then a lot of the underlying infrastructure is kind of like abstracted away. So as an example, if you are building a web app and you want to allow your users to create accounts, sign up, sign in, as a developer using Amplify, you don't even need to know what Cognito is. You simply add authentication, and then in the back end, Amplify will create those Cognito resources, configure them for you, and set everything up. Key emphasis that Amplify does all that work for you. There are two ways to interact with Amplify. There's the Studio, which is like the web portal console version, or there's the CLI, which is a CLI you can use to deploy things, configure things, throw it in CI/CD, and so on. It's important to note that under normal circumstances, doing cloud security research, things are typically pretty opaque. You don't have a lot of visibility into why something happens, unlike, say, for example, like reverse engineering, where you get a little more visibility. As an example, with a previous vulnerability, for some really strange reason, changing the casing of a character managed to break a significant security boundary in AWS. What's neat about this vulnerability, and why it's personally one of my favorites, is that we have a rare glimpse of knowing not only how something became vulnerable, but when. And that's because the Amplify CLI is open source. And so by digging through the commits and looking at the logic over time, we can see how and when things became vulnerable. And we didn't know this at the time, but later on in speaking to AWS employees, we came to find out that the Amplify Studio actually makes use of a lot of the code from the CLI. And that's how I can tell you that on or around July 3rd, 2018, the variant 2 vulnerable trust policy was introduced to both the Studio and the CLI. Whenever you would create an Amplify project, that project would create two roles in your account, the auth role and the unauth role. And unfortunately, with this commit, the default trust policy on those roles looked like this, which is the variant 2 vulnerable trust policy. By simply creating an Amplify project, anybody in the world could now assume roles in your account. And if you gave them those roles any type of privilege, or you wanted your authenticated users to be able to upload a file to S3, read from S3, write to DynamoDB, now anybody in the world, completely unauthenticated, could just do that in your account. Yeah, so like I said, that was introduced on July 3rd. On August 8th, 2019, a little over a year later, AWS actually fixed this issue. They introduced a new change to set the default effect to deny, and they removed the condition. And this is actually the same behavior that you'll see today if you create an Amplify project. Now, it's important to note, when we say fixed, we don't mean, what we mean is that no future roles will become misconfigured. Any ones that were already created are still vulnerable, or were still vulnerable, and could be assumed by an external adversary. Later, on July 22nd, 2020, variant 1 was introduced to the Amplify CLI/Studio. And this one is a bit more complicated. Like I said, you could add authentication to your Amplify app. And if for any reason, at any time, if you chose to delete that authentication component or its resources, and speaking to developers that were affected, the most common reason was situations where a Amplify app started with the built-in Amplify managed Cognito resources, and then at a later time moved to Cognito outside of Amplify, or to just a different identity provider entirely. Whenever you would do that, the Amplify CLI and the Studio would run a CloudFormation template. And in the logic of that template, the default trust policy was originally set to this, which is totally fine. This is secure. However, under the condition for the delete action for authentication, it had a line to delete the condition. And so when it deleted the condition, it set the vulnerable variant 1 trust policy that would allow anyone in the world the ability to assume this role. And again, it's important to note, whatever identity policies you had attached to it, like whatever privileges it still had access to those. So if it could invoke an API, dump a DynamoDB table, it still had those privileges. Additionally, at the end of the day, it's also important to note that these are just plain IEM roles. And unfortunately, a lot of developers like to overprivilege those roles. And so when we were reacting to this vulnerability and notifying customers, we found a number of customers that had highly privileged roles with things like S3 full access, Kinesis full access, and more. And then, of course, between July 2020 and when we disclosed in early 2024, more and more roles were becoming misconfigured and vulnerable. One thing that's really important to stress that makes this sort of worse is that Cognito role ARNs are easily discoverable. If you compare this to the AppSync vulnerability we talked about previously, an adversary who found that would then need to find the role ARNs of their victims. Now, to be clear, an ARN is not a secret, not in the same way an API key or a password is, but it does represent some level of challenge for an adversary. They would have to brute force it, enumerate it, derive it from IAC, pull it out of build logs, extract it from like GitHub and things like that. And so my point is, it requires a more sort of targeted approach where you need to choose a victim and then find a role that you could use to abuse. By comparison, the whole point of Cognito is that these roles are supposed to be for your users and accessible to them. Additionally, they are by default deterministic in the sense that if you know the unauthenticated role, you now also know the authenticated role as well. And so for an adversary who wanted to scale this to the size of the internet, they could make use of the default Amplify app domain, as seen here, and then use Google to crawl tens of thousands of Amplify apps looking for misconfigured roles that they could then assume into. And they could derive them either from pulling it out of JavaScript or by interacting with those identity pools to pull those role arms. And to be clear, the overwhelming majority should be fine, but undoubtedly some number of them will have been created between 2018 and 2019 or have since changed their authentication configuration since 2020. If you'd like to learn more about finding large numbers of Cognito identity pools and their roles, and I apologize, I'm probably going to mispronounce his name, but Andres Riancho has a really great talk from Black Hat 2019 on internet scale analysis of AWS Cognito security. Now, in terms of responding to the vulnerability, AWS did release some fixes in February and April of this year. And to sort of summarize what they did the same thing they did with GitHub Actions, where you can no longer create vulnerable roles in this format. Having a trust relationship back to Cognito, if you try it, the API will reject it, and you can't set it. Additionally, they also took sort of the nuclear approach. And what I mean by that is they actually made changes to STS to prevent you from being able to assume that role in the first place. So even if you had a vulnerable role in your account, an external adversary from a different account could not assume it. If you're interested in this vulnerability and you'd like to learn more about it, AWS did release a security bulletin for it, as well as we have a fairly detailed blog post with some additional details and more. Additionally, this is one of the rare cloud vulns that actually got a CVE, and that's because the Amplify CLI was a local tool that was vulnerable in addition to the studio. And so that's how we got the CVE. Now, really quick, while we're on the topic, I did want to sort of stress or emphasize that anytime you make use of a tool to deploy your resources or configure them, you introduce more opportunity for something to be misconfigured. And AWS is just as capable of misconfiguring something as you are. We saw that with Amplify, and purely by coincidence, literally just last week, AWS released a security bulletin for the AWS deployment framework that had a privilege escalation vuln in it. And so it's really important to consistently and constantly monitor your environment for potential misconfigurations in case they get introduced. Now, additionally, really quick, I did want to mention, we spent a lot of time today talking about creating a resource in your account so that you can go attack somebody else. The reason we do that is simplicity. It's easier if you own it. You can configure it, set it up, do whatever you need, make sure it's always on, right? I wanted to point out that's not strictly required, like in any sense. In particular to like the Amplify vuln we just talked about, you can still abuse this today, same account. And so what I mean by that is if there is a vulnerable role in an account, whether that be variant 1 or variant 2, if there is any Cognito identity pool in the account, not even associated with Amplify, just any identity pool that has the basic offlow enabled, you as an external attacker can interact with that identity pool, pass in the role ARN of the vulnerable role, and still assume it. Now, to be clear, this is more work. It does rely on existing resources to be there, and especially if, say, like the AMR is set to authenticated, you would hypothetically need a user pool configured as well in order to do it. But definitely something to be aware of if you're a pen tester or a red teamer, as this could be used for initial access, or if you're just a heavy user of Amplify. We don't have a ton of time to talk about it, but if you do use Cognito in your organization, I strongly encourage auditing your identity pools and see if any of them have basic offlow enabled, and strongly encourage you to disable it if possible. The enhanced offlow has a number of security benefits that make it a better choice and be worthwhile to use that instead. Now, as a final topic, I want to talk a little bit about what you can do to prevent cross-tenant attacks in your account. To be clear, you would be much better served doing something like deleting all your IAM users, cleaning up old access keys, following least privilege, and so on. But if you're already doing that, or you have the mechanisms and tools in place to support some of these ideas, this might be something you consider. It's interesting to note that AWS provides us a number of condition keys that we can use to limit how somebody can assume a role. And those are source ARN, source account, source org ID, and source org paths. And the way you would use these is add them to a role trust policy to limit how an adversary could get into your account. To be clear, these are not the default. Like if you create an EC2 like an EC2 role and have set this trust policy, it's not going to come with this condition. So you have to manually add these conditions to each trust policy. And you also want to definitely make sure that they still work afterwards. In my experience, they seem to work fairly flawlessly with EC2, Lambda, and AppSync. They do not appear to work with Cognito. I'm not sure if that's just a limitation with assume role with web identity, but anytime I tried to set it, it would just fail. Nobody could assume the role. And the way you would use these is essentially limit either the account or the ARN or the org ID that is trying to assume it. And the neat thing about this is we actually got to see this live actually block me back when we had the AppSync 0 day. As an external attacker, we would be able to assume a role in an account. But if that role had a condition on it that limited the source account, we were unable to assume that role. And the other reason I like these is they're sort of like a backup defense in depth measure, right? If pass role says that under no circumstance should an external adversary be able to assume a role in your account, well, great. In the event that pass role fails, and remember we got around it through memes, so I'm a little worried what other ways exist to get around it. We will double enforce that by setting this condition, which would limit where you're coming from. And so this might be something you consider to apply to your roles. So in summary, we took a look at some vulnerabilities that allowed us to break the shared responsibility model and gain access to AWS accounts. I'd be happy, if you're interested in this research, definitely check out securitylabs.datadoghq.com or follow me on Twitter or Mastodon. Appreciate your time, happy to answer any questions, or if you see me around the con, happy to chat about this as well. Thanks.
One Slack question to get us started. The AWS AppSync vulnerability, was that originally in all public AWS accounts that used AppSync, or was it one of these undocumented sort of early stage things?
Good question. This was in just all AWS accounts that were public. No undocumented APIs were required.
Cool. And then a second question. When you assume 8,000 roles from 8,000 assume role with web identity calls based on roles that you found on GitHub, did you have to do anything to slow it down, hide your activity from AWS monitoring, or just kind of go straight through?
No, everything worked totally normally. I've never had any issues where me exploiting a 0 day has triggered AWS reacting to it. So it was fine.
Okay. Cool. Other questions?
This might be a softball, but what kind of support did you get from your management chain and your colleagues? I know sometimes it's rare to have the right to be a researcher and be poking around for your day job, but what are some lessons some of us might take to organizations that are less well-staffed?
Yeah, no, that's an excellent question. I'd be happy to chat a little more in a not recorded format. I think there's definitely some challenges at a corporate level whenever you're interacting with a cloud service provider and make sure everybody's happy, there's no sort of like altercation. Having a leadership team that is supportive is great. I'm very fortunate that Datadog has a really outstanding leadership team that supports the research we do and sees the value in public disclosure and being honest and truthful with what we find and not hiding things. I totally understand how that can be difficult at some organizations and the pressures that folks will experience.
What was the reason for the CLI deleting specifically just that condition and not the entire role itself?
You know, that's a great question. I spent quite a bit of time looking through the commit descriptions, trying to figure out what caused it, what were they trying to do, and there really didn't seem to be anything specific. I assume it was one of those situations where somebody just said, oh, I guess we don't need it if the effect is deny, and they removed it or something, so don't know.
Anyone else? Oh, one more. All the way in the back.
Hi. What would be your opinion on requiring those, I suppose, those keys that you mentioned at the end there for through service control policies for IAM policies? to help prevent that with more defense and depth and like a guardrail?
Yeah, so SCPs would be a good choice to try and like limit it at the account scale. Personally, I'm always scared, like there are some condition keys that different services don't support. So if you wanted to pursue SCPs, which might be like the most like rock solid defense, definitely test the heck out of it before pushing into production. Because there is the benefit, you could avoid a 0-day, or you could also take down prod. So just be very careful with whatever you're trying to do.
Cool, thank you.
All right, thank you.
All right, thanks everybody.